Yo, this is all about combining like terms. Now, first thing that we're going to talk about is the following. We've been talking about tearing equations apart, how we have to undo the math that's involved. But sometimes before we do that, we have to actually complete some math. And that's what this is all about. Sometimes we're going to need to combine some like terms. We're going to have to put some math together before we can tear it all apart. What do I mean by that? I mean, we could have an equation that looks something like this and put it off the side, like 3x plus 4 minus 2x plus 7 equals 9. So if I take a look at that, it's like, okay, if I said, all right, I want you to tear everything apart that's attached, it's like, whoa, there's stuff attached to this x, stuff attached, like, well, where do I start? So sometimes we might run into something like this and we say, you know what we got to do here is we've got to actually perform some math before we can tear it apart. Now, how do I make that happen? Well, it's kind of simple. First off, when we're talking about combining like terms, what I'm talking about here is two things. One, combining means we are adding. Okay? Regardless of whether they're positive or negative, we are going to be adding those like terms together. And two, it is only the like terms, which is a fancy way to say, hey, those guys are identical. Like terms have to have the following. They have to have the same variable or variables to the same power. Now, I only say that just because it's true. We don't have any exponents right now, so you don't have to worry about that. But I did want to mention that because at some point in your algebraic career, they will have some variables. This year, same variables, same power, or constants. And we know what constants are. They're the guys without any variable. So now, take a look at the problem that we have before us. It says 3x plus 4 minus 2x plus 7 equals 9. Again, I can't solve that because I take a look at it and I'm like, okay, I got x's everywhere, I got constants everywhere. I can't really solve it. So what I'm going to do is I'm going to realize there's some math here that I can actually perform. So we're going to do that. What math am I going to actually perform? I'm going to go ahead and identify those like terms. And I like to do like the old circle box thing. That's what I like to do. So I'm going to take a look and I'm going to go, okay, well this 3x right here, he is a variable of x. There is another one. He also has a variable x. Notice when I circle him, however, I'm including the sign in front of him. Because when I go to add those together, I'm going to know what sign's in front. Then I go to my constants. I have this positive 4 here, and I have this positive 7 here. That plus, now that you look at it just by itself, just means that it's a positive. We'll start with the variables. I have a 3x, and I have a negative 2x. When I add a 3x and a negative 2x, I will now have a 1x. I then will take my positive 4 and my positive 7. I'll add those together, and I will get positive 11, or in this case plus 11 because there's something in front of it, and that's going to go ahead and equal 9. At this point now, that is actually a single step equation, and that should be fairly easy for us to fix from there. I do want to caution you, well, let's go ahead and finish it up. I'm going to take a look at this and say, hey, what's attached to x? Well, I have a 1 by multiplication and 11 by addition, so I get rid of the addition first. I'm going to subtract 11, subtract 11. That's going to give me 1x. This cancels out, and that's going to equal negative 2. Now, I can go ahead and do something with that 1x, but I can also recognize that 1x is the same thing as x, so I can just erase it if I want. That's my answer. Now, when you go to do the 3-step check, go back to the original problem. Too many kids like to go here and try to plug it into there. Don't do that. If you made a mistake when you're combining like terms, that won't be reflected here and you'll look like you're right when you're not. So always go back to the original. So the original was 3x plus 4 minus 2x plus 7 equals 9. We're now going to go ahead and substitute all those values in. We think that x is negative 2, so we're plugging it in, negative 2. And now, if I grab my calculator, which I will, I'll plug that all in, and I'll wind up with, whoa, calculator says low battery, and it's solar powered. Plus 4 minus 2, parentheses, negative 2, and I'm typing in it exactly as I see it. I'm going to press enter, and boom, got my 9. So that tells me 9 equals 9. This checks out. Don't forget to put that as a solution set. I'm out of room, I see on my screen, so I'm going to put it over here. Sorry, I'm kind of limited with just this little screen area I have. Okay? Hopefully that makes sense. Let's try one more. This whole combining of like terms is actually a fairly simple concept. It's just another little wrinkle in what can happen when we run into one. Oh, I have a great idea. Let's give you some crazy looking one. Let's say that 12 equals 4 minus 3b plus 2b plus 8 minus 7. Where are we at here? Plus 8b. Let's try that. Let's see how that works out. So now I've got all kinds of stuff in here. And it's on that side we don't like to see it on, but that's okay. So as soon as I look at that, I go, okay, what's attached to my variable? Like, what's the math I got to tear apart? And I look at it and go, well, can't really tear all that math apart until I put some of it together. So I'm going to take a look at this and go, okay, on that side I have some like terms. So I'm going to go ahead and just put 12 down here. And I'm going to identify my like terms. I'll start with my constants. Here I have a 4, he's a positive. I have an 8, positive. I have a 7, but he's negative. Then I go to my variables. I have a negative 3b, positive 2b, and a positive 8b. So when I go ahead and gather up like terms here, I'm going to have the following. Negative 3b and 2b is negative 1b. Add that to 8b, and I'm looking at 7b. Then I'm going to have my constants. 4 and 8 is 12. Subtract 7 from that. I'm looking at plus 5. So now I'm going to go ahead and solve this. Subtract 5 from both sides. That gives me 7 equals 7b. Divide both sides by 7. 1 equals b. Once again, got that ugly thing to check, but calculator will do the work for me if I want. So here we go. We're going to rewrite the initial equation because we always want to go back to the start. I'm then going to go ahead and substitute in what I think b is. We think it's 1. I think it's 1. I hope you also think it's 1. And then we're going to check and see what we got. So grab my calculator here. I'm going to punch in 4 minus 3 times 1 plus 2 times 1 plus 8 minus 7 plus 8 times 1. Now that we're several, I got 12. Now that we're several objectives into this, I'm sure a lot of you, don't forget to put your equation in set notation. I'm sure a lot of you are looking at this and going, you know what? It'd be really nice if I had one of these. When you don't, so keep in mind, these are TI-30XS's multi-views, which means you can do it in math print or not. I think you can get these for 20 bucks or under, okay? And I hate to make any sort of financial burden for anybody, but if you can spare the 20 bucks and get it, I would, or ask for it for early Christmas present or something. Make your life a lot easier, okay? That's gathering like terms or combining like terms. Hopefully you find that pretty easy, and I'll see you later.